Hi there. Find f of x if f of g of x is equal to f of x times x plus 1 times x plus 2 minus 1 and g of x is equal to x cubed plus 2x squared minus x minus 2. So before we solve this one, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. So to solve this, first take note that in g of x, take note that by factoring, by grouping, we have this, or we can write this one as x squared times x plus 2. So we factored out x squared out here, and we factored out the negative out here. So we have x squared times x plus 2 minus x plus 2. Then since these two are the same, we can factor this one out. So we'll have x plus 2 times x squared minus 1. Now by difference of two squares, take note that this one factors into x minus 1 times x plus 1. And so g of x is equal to x plus 2 times x minus 1 times x plus 1. What this tells us is that the zeros of g of x are negative 2, 1, and negative 1. So technically, this just tells us that if we plug in negative 2, 1, and negative 1 in this function, the output would be 0. Since clearly if we plug in negative 2, this becomes 0, and so on. So we'll be using this fact later on. Now, moreover, take note that f of g of negative 1, we know that g of negative 1 is equal to 0. So we have this to be 0, and so this is just equal to f of 0. And then we apply this given equation, this given function, this given equation out here into x equals negative 1. So if we do x equals negative 1, this becomes negative 1, negative 1, and negative 1. So we have f of 0 equals f of negative 1 times negative 1 plus 1 times negative 1 plus 2 minus 1. Take note that negative 1 plus 1 is equal to 0. And so this whole expression out here becomes 0. So this one just cancels out and we'll be left with negative 1. So this means that we have f of 0 equals negative 1. And that. So we take note of this one. Aside from this, take note that f of g of 1 is equal to, again, g of 1 is equal to 0 from here. So this one is just, we have 0, so this one is equal to f of 0 as well. And then we apply this one out here to this. So we just replace x with 1. This one is 1, 1, 1, and 1. So we have f of 0 equals f of 1 times 1 plus 1 times 1 plus 2 minus 1. Take note that from in here, we know that f of 0 is equal to negative 1, then 1 plus 1 is equal to 2, and 1 plus 2 is equal to 3. So this one out here simplifies too, so we just multiply this to obtain 6. And so we'll have negative 1 is equal to 6 times f of 1 minus 1. And then adding both sides, adding 1 both sides, will cancel out the negative 1. And so we'll be left with 6 times f of 1 equals 0. Divide 6 both sides and we get f of 1 equals 0. So take note of this one as well. So far, our important results are f of 0 equals negative 1 and f of 1 equals 0. So let's clear out some space and move this up. Now in here, let's try to inspect the degree this time. Degree in this one. So take note that the degree of g of x is clearly 3 since its highest exponent is 3. For f of x, we don't know its degree since this is what we want to find. So we can set f of x, or the degree of f of x, to be a. Now, let's use this one out here. So observe that in here, let's focus first on the right hand side. So we know that the degree of f of x is a. The degree of x plus 1 is clearly 1 since this one is just linear, and so is x plus 2, just 1. For this one, it's just degree 0, so we disregarded 1. Now when we multiply this, take note that by loss of exponents, what we do in exponents is we add them. So we know that the highest degree for this one is a plus 1, or when simplified is a plus 2. So the degree of this right hand side is a plus 2. For this other one, take note that, so suppose if we have f of x equals x raised to a plus so on, and for g of x, so let's just use the x cube out here. So we know that this one is degree 3 and this one is degree f. If we have f of g of x out here, then this one becomes x cubed raised to a and so on. So we know that the highest degree has a degree of 3 raised to a. So we have this. So the degree of this one is 3 raised to a. And since this one is equal, then we know that their highest degree, or their degree in general, must be equal. So we have 3 raised to a equals a plus 2. And it is not hard to see that clearly a must be equal to 1. Since if it is equal to 1, then this becomes 3. And on the right side, we have 1 plus 2, which is also equal to 3. So we have a equals 1. Or the degree of f of x is equal to 1. This means that f of x is linear. So we can express f of x as ax plus b with unknown coefficients. So far we are getting close to what we want since we kind of have a good idea already of what f of x is. We know that it is linear. The last question is to find these unknowns, but fortunately we are given this 2 out here. So given this two values of f, we can find the two unknowns. So starting with f of 0, we have f of 0. So plugging in 0 out here, we have a times 0 plus b. Then a times 0 will just cancel out, so we'll be left with b. And from in here, we know that f of 0 is equal to -1, so we have b equals -1. So we now have a value for b. Now let's solve for a. Let's use this one. So we have f of 1, so plug in 1 out here. We'll have a times 1 plus b, or when simplified is a plus b. Then from in here, we know that f of 1 is equal to 0, so a plus b must be equal to 0. Then, in here, we know that b is equal to -1. So this one is equal to -1, so we'll have a minus 1 equals 0, move -1 to the right, and we'll have a equals 1. So we now have a value for a and b. Lastly, we just plug in these values to our given out here. So if this one becomes 1 and this one becomes -1, then we'll have 1 times x plus -1, or when simplified is f of x equals x minus 1. This out here is our final answer. So did you got that one correctly? I hope you did. Feel free to comment down below if you have any questions, suggestions, and recommendations. And even if you have other solutions on how to solve this one, feel free to comment it down below, and that would be great to hear. So yeah, that's it, and that's all for this how to solve video.